Okay, let's solve this linear programming problem using the simplex method, and we want to maximize this objective function with these constraints over here. Now, first thing you want to note is that this is not in standard form, and the problem we have over here is that this inequality is greater than or equals to 6, but I want everything to be less than or equals to some number. So I want less than or equals to, but we have greater than or equals to. So first thing we want to do is we want to fix that. And to flip this inequality, I can multiply my entire equation by a -1, and that should fix it for me. So I will take that equation, multiply the whole thing by -1. Don't forget to distribute it through. And my new constraints then will be x plus y is less than or equals to 3. Now we have positive 2x minus 3y less than or equals to -6. X greater than or equals to 0, y greater than or equals to 0. All right, now I have everything that is less than or equals to. My variables are greater than or equals to 0. And I am also asked to maximize an objective function. Everything's in standard form now. Now I can proceed and come up with the slack variables. So let's introduce slack variables. I have two equations. So I will let u be greater than or equals to 0 and v be greater than or equals to 0, such that my first equation plus u is equal to 3. The second one plus v is equal to -6. And I also want to maximize this objective function up here. So let's let m be as large as possible such that it equals the objective function. So let m greater than or equals to 0 be as large as possible such that m is equal to my objective function, which was 80x plus 60y. Now, I don't like that I have variables on both sides of the equation here, so let's subtract 80x, subtract 60y to get everything to one side and set it equal to 0. All right, cool. Now I have all of these equations that are equal to some constants. I can set up my simplex tableau. So let's set up the simplex tableau. Let me zoom out a little bit so I can fit everything in here. Again, we have x, y, u, v, and m. My solutions on this side. My not variables, the coefficients for the variables on the other side. So we have 1, 1, 1, 0, 0, 3, 2, -3, 0, 1, 0, -6, and then we have -80, -60, 0, 0, 1, 0. Let me draw a line down here. These are, my objective function is on the bottom. Okay, now I want to start getting rid of negatives, but I want to do this in a way where it's the way that will maximize it. So I don't want to just randomly pivot things. I want to pivot them with a strategy that I am going to maximize this function. So first thing we want to do is check the column that is on the right side of that bar. I want to check these two specifically. Do I have any negatives? Yes, I do. Here is a -6. So I want to take this -6 and get rid of it. Now, how do I do that? I will look in the row that the -6 comes in and look for a negative number in that row. There's my negative number. That is going to be my pivot element. So let's circle that. That's what I'm going to pivot, meaning I am turning that into a 1. So to turn that into a 1, I will multiply that entire row by negative 1 over 3. So negative 1 over 3, row 2 into row 2. Rows 1 and 3 stay the same, so I'm going to copy those down. Rows 380, negative 60, 0, 0, 1, and 0. Row 1 gets multiplied by negative 1 over 3. So this becomes negative 2 over 3. I get 1, 0, negative 1 over 3, 0, and 2. All right, so now we have our 1 where we want it. Let's focus on making these two zeros. So multiply row 2 by negative 1 added to row 1. Let me copy down row 2 the way it is. Okay, we have 5 over 3, 0, 1, positive 1 over 3, 0, and 1. To make that a positive, I am going to multiply, or sorry, to make it a 0, I'm going to multiply by positive 60, row 2 plus row 3, and row 3. Okay, so we have 60 times negative 2 over 3 minus 80. That gives us negative 120. 60 minus 60 is 0. 0 plus 0 is 0. 60 times negative 1 over 3 is negative 20 plus 0, that's negative 20. 60 times 0 plus 1 is 1. 60 times 2 plus 0, that's 120. Right, so I pivot it. Now I look at my row on the bottom. Look for the more negative value. So negative 120 is definitely more negative than 20. So that's where my pivot element will come from. And then I want to look at ratios and find the ratio that gives me the least positive value. Well, if I do 2 divided by negative 2 over 3, that's going to give me a negative value, so I don't even have to check that ratio. The only other option I have would be this 5 over 3. So that is the only one that's going to give me a positive ratio. So my pivot element becomes this 5 over 3. How do I turn 5 over 3 into a 1? Multiply it by the reciprocal. So multiply by 3 over 5. Oops. Let me switch colors. Okay, so 3 over 5, row 1 and row 1. 1 over 5, 0, and 3 over 5. Okay, now I'm going to combine this next step and turn these into zeros and just continue that on. So multiply row 1, or new 1 that we have, by positive 2 over 3 added to row 2. So 2 over 3, row 1 in plus row 2. In row 2, we get 0, 1, 2 over 5. 2 over 5, yes, 2 over 5 plus 0. And then we have 2 over 15 minus 1 over 3. -1/5, 0, 2/5 plus 2 gives me 12/5. Okay, now let's get rid of that last one. Make that a 0. So multiply by +120, row 1, add it to row 3, put it in row 3. We get 0, 0. 120 times 3 divided by 5, 72. 120 divided by 5 minus 20 gives me 4. 1 and 192. All right, again, I go and check my last row. I don't have any negatives anymore, so my maximum has been reached. Now I just need to figure out what my group 1 and group 2 variables would be, and then from there, I can read off my solution. So we have x, y, u, v, m. If I let u be 0 and v be 0, then x, so these go away. X is 3/5. And y would be 12/5 with the maximum. So these are again gone. M is 192. So write that in a sentence. The maximum is 192 at our point 3512.5. And we are done with that. Now moving on for the second one. We want to solve another linear programming problem using the simplex method, but in this case, we want to minimize some objective function. So first I'm going to check and see if this is in standard form. It's not. There are two equations that are greater than or equal to 0, so I have to fix those first. Then I have to worry about how do I minimize. So let's fix my equations by multiplying each one by a -1. So we have -2x minus 5y less than or equals to -35. We have positive 3x minus 5y less than or equals to -10. This one stays the same. And okay, now everything is in less than or equals to form. So I can introduce some variables. And I need more than the ones we've been dealing with, but that's okay. We can do a whole bunch of them, and that's fine. As long as we follow that same step, we're going to do it right. So I will let u be greater than or equals to 0, v, w, and t. Whatever variable you want to pick, that's not used already. So such that my inequalities now become equations. So plus u is -35. Here we have 3x minus 5y plus v, -10. We have 8x plus 3y plus w, 92. -9x plus 7y plus t, 49. And then we let little m be as small as we want it to be, or I can think about minimizing something is this opposite of maximizing. So if I take this objective function and find the opposite of it and maximize that, that will give me the same thing as minimizing the original. Meaning if I multiply, so let's actually make a note of that. Note. So minimizing our original, which is, I already forgot what it was, x plus 9y is the same as maximizing the opposite. So negative x minus 9y. So now let m be as large as possible. Such that negative x minus 9y is m. Get everything to one side of the equation. I'll have positive x plus 9y plus m is 0. Set up your simplex tableau. Okay, let me write everything down. So we have x, we've got y, u, v, w, t, and m, and then our solutions. So here we have -2, -5, 1, 0, 0, 0, 0, -35. Seven, 0, 0, 0, 1, 0, 49. And finally, I have 1, 9, 0, 0, 0, 1 and 0. Okay, now, first thing you want to do is check that last column, the upper side of that column, see if you have any negatives. I have 2 negatives. Second thing, let's get the ratios. We still want that smallest positive ratio. So checking the ratios of the negatives because that's what I'm trying to get rid of. This one right here, this will give me -35 over -5, +7. Whereas this one is -10 over -5, which is +2. So that is a smaller ratio. So that should be the one I want to pivot. Also, if I took these two ratios, that still is going to give me a bigger number. So I don't have to worry about those. All right, so that -5 is going to be my pivot element. So let's multiply my entire row by a -1 over 5. Row 2. And I need a lot more space, but that's okay. Actually, let me just start fresh, add a new page. This is a bigger page. I like it. Let's do that. So -1 over 5, row 2 and row 2. The other rows stay the same, so I can just copy and paste that down. So let me do that. And I will erase row 2 and substitute it in here. So all of that changes. Let's fix these. Okay, so we get negative 3 over 5, 1, 0, negative 1 over 5, 0, 0, 0, and positive 2. Now let's make these ones into zeros. So multiply 5 row 2 plus row 1 in row 1. Negative 3 over 5. I'm just copying row 2 down the way it is. Okay, so multiplying by 5, adding, we get negative 5, 0, 1, negative 1, 0, 0, 0, negative 25. Multiplied by negative 3, row 2 plus row 3 and row 3. 49 over 5, 0, 0, 3 over 5. Multiply by negative 7. Row 2 plus row 4 in row 4. Negative 24 over 5, 0, 0, 7 over 5. And then finally, negative 9. Row 2 plus row 5 in row 5. Okay. Again, I have that same issue going on. I still have a negative value. So let's choose one of these and pivot them. And in this case, I can choose either one, either the 5 or the negative one of the negative elements in there. I'm going to choose negative 1. It's easier to pivot that negative 1 initially than it would be to divide by 1 over 5. It doesn't matter which one you choose. You're going to get to the same solution in the end. It's just that which one do you prefer to choose? Right, so multiplying that entire row by negative row 1. So negative 1 times row 1, put it in row 1. Now we get positive 5, 0, negative 1, 1, 0, 0, positive 25. Okay, now let's turn everything underneath it into zeros. Multiply by 1 over 5, row 1 plus row 2 in row 2. We get 2 over 5. 1, negative 1 over 5, 0, 0, 0, 0, 7. Multiply by negative 3 over 5, row 1 plus row 3 in row 3. 34 over 5, 0, 3 over 5, 0, 1, 0, 0, 71. Moving on to the next one. We need to multiply by 7 over 5. Negative. Negative 7 over 5, row 1 plus row 4 and row 4. Now we get negative 59 over 5. And last one, 9 over 5. So negative 9 over 5, row 1 plus row 5. And row 5. All right, now I don't have any negatives. Oops, let me go back. All right, I don't have any negatives here. Now I can worry about my last row and see if I have any negatives. I do, right here. So here's where my pivot element is going to come from that column. I have to take the ratios of every single one of these with the solution and see which one produces the smallest ratio. So I want the smallest positive ratio. This right here will give me 0. I'm not going to check it. Here we have 35 over 2. Here we have 71 times 5 over 34, 355 over 34. And here we have 5 divided, or 25 divided by 5, which is 5. This produces the smallest ratio. So my pivot element is this 5 over here. Pivot it. And I'm not going to write all the steps. I'm just going to pivot it until we get this matrix over here. And you guys can pause this, pivot it, see if you are getting the same thing. So same steps. Get a 1 instead of where the 5 is and get zeros underneath it. And this is honestly as ugly as they get. So if you can do this, you can do any of them. If you know how to do this, none of them can scare you anymore. Okay. Now let's look. I don't have any negatives on the last row. Sure hope I don't have any negatives on that column. If I did, this is what I needed to take care of before I even looked at anything else. Okay, so let these two be 0. So let's talk about what they were again. This is X, Y, U, V, W, T, and M. So I'm going to let U and V be zeros. Get rid of those. I really only care about X and Y, then X is 5 and Y is also 5, with M being negative 50. But again, I don't want M, I don't want capital M. I don't want the maximum, I want the minimum. So this is max is 50, is negative 50, which tells me minimum is positive 50. So minimum 50 when X is 5 and Y is 5.